Imagine you're playing D&D and you as a wizard come across a sword and a stone and you want to know the probability that that sword is cursed. How can we do that? Turns out there's actually some really intuitive maths that can help us work this out. And it's called Bayes' theorem. Now the maths looks like this, but don't worry about it because it is actually a really human way of understanding probability. Let's talk about what things like A and B mean. Well, A is the event that the sword is cursed, and so P of A is the probability, or our prior probability, that the sword is cursed. But probabilities aren't always independent, like the odds of me having an umbrella with me do depend on the evidence that it's raining outside, and that's what B is. B is our evidence. So let's say that B is the evidence that the sword is engraved. And now these bigger symbols here, what this means is the probability of B given A. So in our example, what this means is the probability that the sword is engraved given that it is a cursed sword. So this is assuming that A is true. So let's see in this example, right? Let's assume you're pretty confident. You're like, yeah, it's probably not a cursed sword. It's a 1 in 100 chance. You failed a perception check, obviously. But on closer inspection, you see that the sword is engraved. So B is going to be that it's an engraved sword. And let's say in this world that the probability of an engraved sword being cursed is 3 in 5. People aren't doing it all the time, but maybe it's blessed, who knows. Now the probability that the sword is engraved, we just put through this equation here. So this is our probability that the sword is engraved given it's cursed, which we have above, and the probability that it's a cursed sword, which is 1 in 100. Well, this comes out to about 0.402. And this means that our probability that the sword is cursed, given that we've seen it as engraved, has actually gone up a little bit from our prior probability. And as you reach your hand closer, the sword begins to glow. You know what that means? We can do this all again. Our probability that it's cursed is now going to be this one. We're just going to take this new evidence in our stride and update our prior. Let's say that the odds that the sword is going to glow, given that it's cursed, is 9 out of 10. Glowing is bad. Glowing's a bad form. And plugging that all in, we find that the probability that the sword is cursed, given that it's glowing after we found that it was having engravings, is now about 60%. So we've gone from a 1% probability to 60% because we've seen more evidence. So this is why it's so intuitive, right? The probability that something is true is given on the evidence. And now let's say the sword talks to you and says, "Buh, I am cursed." P of B given A. The probability the sword says, "I am cursed," given that it is cursed, is 100%. And this is really cool, and this is how we update our beliefs. This is used in science all the time, but we could also use it in D&D. For example, each of these steps could be an investigation roll. Obviously, your party might hate you if you slow everything down to do the maths, but frankly, I think it's very in line for a wizard. Anyway, I hope this made sense. Have a lovely day. Okay, bye.